Okay, so here I have written down our problem on the board. Miss Kaufman has 3/4 of a candy bar. She gives 1/3 of her candy bar to Miss Park. How much of the candy bar is left? I began by writing the problem I need to solve, which is 3/4 minus 1/3, because we're taking away 1/3 from Miss Kaufman's candy bar. So first, we're going to draw our two rectangles. So this first rectangle right here is going to be my 3/4. So I'm going to show 3/4 in this rectangle. I'm going to go ahead and split it up into fourths. And then I'm going to color in 3. So now I have 3/4 in the first triangle. For the second triangle, I'm going to show 1/3. And I'm going to split it up this way into thirds. And I'm going to show 1/3. So the next step is to think of a number that both 4 and 3 can go into. It would be best to look for the least common denominator, or the LCD. And an easy way to do this is, if you're looking for one, you can start listing all the multiples of the numbers, of the number that you're trying to get the least common denominator for. 4, 8, 12. All right, so it looks like 12 is our least common denominator. Okay, so now that we have our least common denominator, we want there to be the same amount of pieces in both of these, and both of these will go into 12. So we're going to make sure that this splits up into 12. So we have to think 4 times what equals 12? 3, right? So we're going to split this up into 3 rows. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 twelfths. And the same with this one. 3 times what equals 12? 3 times 4. So we're going to split this up into 4 columns. Now we have 1, 2, 3, 4. 4 twelfths. And you see, the important part of this model is that it's showing that you're making the pieces an equivalent size, or an equal size. So we're able to subtract these pieces from each other because they are the same size. So now we know we have 9 twelfths minus 4 twelfths. And if we want to take away, we can see these pieces right here, 1, 2, 3, 4. We can take away 4, 1, 2, 3, 4. And how many do we have left? 1, 2, 3, 4, 5. So we have 5 twelfths of the candy bar left, which you could also have gotten if you just subtracted 9 from 4, and I would keep the bottom the same.